Hello, Mr. Corbett, and this is going to be my first mastery assignment. I like these videos. If you keep doing this tic-tac-toe thing, I will keep making these videos because I think it's awesome. But anyway, this is Sean Cherry, and I'm from your fourth period class. We're going to be talking about three events: the Big Bang, and then the layers of the sun, and then a sun's lifetime, and what happens during it. So the Big Bang was basically a huge explosion in our universe. And it was so hot and it was just so hot that it created matter and antimatter. It also created energy, which was protons, neutrons, and electrons. And then it also created one of the first elements called hydrogen. And hydrogen is an element. An element is basically the basic building blocks. You know, hydrogen plus hydrogen equals helium, and helium is what we use for balloons. But anyway, the evidence of knowing about the Big Bang is that when you have such a huge explosion, or any explosion for that matter, everything slowly starts to move away after the explosion, like an aftershock event. We know this because of the Doppler effect. When an object is moving, it creates these sound waves. If it's coming towards you, these sound waves are compressed. And if it's moving away from you, they are more spread out. And they are more spread out from what we learned on Earth, so this just proves the fact of that. And also, if our eyes were much more sensitive to color, we would know that if something was moving towards us because the object changes its color to slightly blue. If it was moving away, it would be red. So we use some telescopes and we look at the planets and we could see that they're kind of red than what we can see. That's because they are all moving away. I'm going to show you this interesting Minecraft thing. So basically here it is. This is the brown is matter, let's say, and let's say the black is antimatter. And matter and antimatter were created in the Big Bang, and they don't really like one another. So they come closer towards each other. And then when they touch each other, there is this huge, hmm, hmm. There's this huge explosion like this, and they both basically destroy themselves. Now, thankfully, there was more matter than antimatter. So that's when all the antimatter was destroyed, and that was when only matter survived, which created this universe, its planets, and our own galaxy. Moving along. Now I'm going to talk about the stars later. Okay, so first there's the core. Nuclear fission happens here. It's basically how the sun creates its own energy. This photosphere is something, well, that's kind of moving out. Let me talk about the radiative. The radiative zone is how the energy goes through some of the sun. And because the sun is creating so much energy, there's all these different types of protons. Because there's so many protons, they're bumping against each other, so it's really hard to get into the convective zone. In the convective zone, it's where the energy is, well, convected. I mean, if you think of heat, it's going to have the cycle, and that's where this cycle happens in the convective zone. And the photosphere is what we see most of the sun. It's what produces all the light. And if you look into the sun, which is not a good idea, that's what we would see, the photosphere. The chromosphere is protects. It stops any harmful particles from moving out of the sun. But sometimes things do escape because No, that's sorry. I'm sorry. That was wrong. The chromosphere is what is the fiery stuff that is happening on top of a star. And if we would look at our sun, if we saw a total solar eclipse, that's what we would see, because the photosphere is blocking out the chromosphere. But when the photosphere is blocked out, we can see the chromosphere. The corona is what I was talking about earlier. The corona stops harmful particles from moving out of the sun. But because everything is not perfect, some things do escape, and we call these things solar wind. This is a life story of a cycle. And let's start with what our sun would go through. First, it would be created in the stellar nebula, which is basically the birthplace of stars. And then it would turn into what our sun is. But we'll probably be, but yeah, and it's halfway through its life. But when it's over the half of its life, it will turn into a red giant, which, if you have so much heat, it's going to expand rapidly at one point. And then that's what creates a red giant. And then, after burning out, it becomes a nebula for a while. And then a white dwarf. White dwarfs are basically what we see in the sky, or like twinkling, but they burn out over time, and then they turn to black dwarfs because we can't see them anymore. If we were talking about another star which is huge and massive, first it would be like our average stars, that bigger and hotter. Then, when it got to the red giant stage, it would actually become a red supergiant, which is quite mean, even though it's not red. But anyway, then it would quite explode and become a supernova. And then at that point, it would either become a black hole or a neutron star. And yeah, that's it. Thank you for watching, and I will see you tomorrow. Goodbye.